Welcome to Space in Minutes, where space meets simplicity. New videos drop weekly, so subscribe and join our awesome cosmic community. If you're excited about making space more accessible for everyone, why not join us as a member? Your support really means everything to us. As a member, you can enjoy our videos without ads and help us create even more awesome content. Did you know there's something in space so dense that even light can't escape it? We can't see them, but we sure can feel them. So, what's a black hole really? Black holes are one of the strangest and most extreme things in the universe. They warp space, stretch time, and can swallow stars whole. But they're not just cosmic monsters. They are also windows into the deepest laws of physics. Today, we're going to break down what black holes really are, how they form, what they do, and why they might even shape the universe. At its core, a black hole is a region of space where gravity is so strong that nothing, not even light, can escape. But it's not really a thing. It's more like a place, a distortion in space-time. This happens when an enormous amount of mass gets squeezed into a tiny volume. The result? A kind of invisible well in the fabric of the universe. Imagine putting the mass of the sun into something the size of a city. Oh, stuffing Mount Everest into a pinhead. That's how extreme it is. The edge of this well is called the event horizon, the point of no return. Once something crosses it, it's gone. But how did these cosmic monsters come to be? Most black holes form when massive stars die. When a giant star runs out of fuel, it collapses under its own gravity. If it's big enough, the core gets crushed down into a black hole. There are also supermassive black holes, millions or billions of times heavier than the sun, sitting at the center of most galaxies. How they formed, still a mystery. And there are also primordial black holes, hypothetical ones that may have formed in the earliest moments after the Big Bang. Now, let's dive into the weirdness of what happens inside a black hole. This is where things get strange. Physics, as we know it, just doesn't apply here. At the center, there's what's called a singularity, a point of infinite density and zero volume. We don't really know what happens there. Our math collapses. In time, it stretches. The closer you get to a black hole, the slower time flows, at least from the outside. It's like watching a clock slow down the closer it gets to the edge. From far away, it looks frozen in time. But if you were falling in, it would feel completely normal for you. But black holes aren't just cosmic oddities. They actually do stuff. They don't just suck things in. Black holes can shape galaxies. The supermassive one at the heart of the Milky Way may have helped form the structure of the galaxy itself. They also release enormous energy when feeding. Matter falling into a black hole gets superheated and can shoot out jets of plasma traveling near the speed of light. Imagine flushing a bathtub with too much water. It swirls faster and faster, heating up, glowing, then blasting jets into space. In fact, some of the brightest objects in the universe, quasars, are powered by black holes. They're totally invisible, but definitely not silent. Now, let's talk about something a bit more personal. Can you fall into one? What would it feel like? If you did fall in, you'd experience spaghettification. Yes, that's the real word. To be stretched thin, pulled apart by gravity's difference between your head and feet. It's like hanging from a rope over a waterfall, with your feet being yanked harder than your head. Eventually, snap. But from your point of view, you'd just cross the event horizon with no drama. So someone watching from afar, though you'd appear frozen, forever hovering at the edge. This contradiction is one reason black holes fascinate physicists. They force us to ask, what's real, what's relative? Now, here's a mind-bending question. Do black holes last forever? Nope. According to Stephen Hawking, black holes slowly evaporate through something called Hawking radiation, tiny particles escaping over time. For a big black hole, that process takes trillions of years. But in the end, Even black holes might disappear, fading into nothing. Think of it like a slow leak in a tire, invisible at first, but eventually it empties out. That means they're not just cosmic garbage disposals, they're temporary features of the universe. So, what exactly is a black hole? It's not just an object. It's a place where space, time, and gravity collide. They're terrifying, mysterious, and maybe even beautiful. And the more we study them, the more we learn about the universe and about ourselves. If you enjoyed this, subscribe to Space in Minutes. We've got more cosmic questions, bizarre theories, and science made simple, all in under 10 minutes. And if you've got a black hole thought or theory of your own, drop it in the comments. I reply to everyone. See you in the next video, and don't fall in. Now, let's dive a bit deeper into some of the fascinating aspects of black holes we've touched on. Remember when we talked about the event horizon? That's not just some arbitrary line, it's a fundamental boundary in physics. Inside the event horizon, the very nature of space and time flip. What was once space becomes time, and what was once time becomes space. It's as if the universe turns inside out, and that singularity at the center is not just a point of infinite density. It's where our current understanding of physics breaks down completely. Some scientists think it might be a portal to another universe. Others believe it's where quantum mechanics and general relativity finally meet, potentially leading to a theory of everything. Let's talk more about those supermassive black holes at the centers of galaxies. Our own Milky Way has one, called Sagittarius A*. It's about 4 million times the mass of our Sun, but that's tiny compared to some others out there. The largest known supermassive black hole is in an elliptical galaxy called TUN 618. It's estimated to be 66 billion times the mass of our Sun. These cosmic giants don't just sit there. They're dynamic, They grow by consuming gas, dust, and even whole stars that venture too close. When they feed, they can create some of the most energetic events in the universe. Remember those quasars we mentioned? They're like cosmic lighthouses, visible across billions of light years. A single quasar can outshine an entire galaxy, and it's all powered by a feeding supermassive black hole surrounded by a swirling disk of superheated material. But black holes aren't always destructive. They might play a crucial role in the formation and evolution of galaxies. The jets they produce can trigger star formation, spreading heavy elements across vast distances. In a way, black holes might be cosmic gardeners, planting the seeds for new stars and planets. Now, let's circle back to that mind-bending concept of Hawking radiation. It's not just a slow leak, it's a fundamental challenge to our understanding of information in the universe. See, quantum mechanics says information can't be destroyed. But if a black hole eventually evaporates, what happens to all the information it swallowed? Is the famous black hole information paradox, and it's still unsolved. Some theories suggest the information might be encoded on the event horizon, like a cosmic hologram. Others propose it might leak out with the Hawking radiation. Or maybe it creates a new universe inside the black hole. The truth is, we don't know, and that's what makes it so exciting. Black holes also give us a unique laboratory to test Einstein's theory of general relativity. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole's shadow. It matched Einstein's predictions perfectly, once again confirming his century-old theory. But general relativity and quantum mechanics, our two best theories of how the universe works, don't play well together. And nowhere is this conflict more apparent than in black holes. That's why many physicists believe that understanding black holes could be the key to a unified theory of everything. Let's not forget about those primordial black holes we mentioned earlier. They exist. They could solve several cosmic mysteries. They might explain dark matter, the invisible stuff that seems to hold galaxies together. They could account for the supermassive black holes we see in the early universe. Some even speculate that our universe might have been born from a black hole in another universe. And here's a wild thought. What if we could harness the power of black holes? Some far future civilizations might use rotating black holes as a power source, extracting energy through a process called the Penrose process. Or they might use them for interstellar travel, riding the jets of plasma to reach distant stars. But for now, black holes remain mysterious cosmic beacons, challenging our understanding of the universe. There, where the very large gravity in space-time meets the very small quantum effects. There, where our theories break down and new physics might emerge. Every time we learn something new about black holes, it seems to raise even more questions. Are they gateways to other universes? Do they hold the key to understanding quantum gravity? Could they reveal the deepest secrets of space and time? As we continue to observe and study these cosmic enigmas, who knows what we'll discover? The journey into understanding black holes is really a journey into understanding the fundamental nature of our universe. And that's a journey that's only just begun. So the next time you look up at the night sky, remember, hidden in that darkness are objects so extreme they bend the very fabric of reality. It's black holes, nature's ultimate mystery, waiting to be unraveled. Keep wondering, keep questioning, and keep exploring the cosmos, because in the end, every discovery about black holes is a discovery about ourselves and our place in this vast, strange universe. Until next time, this is Space and Minutes, making the cosmos a little less mysterious, one video at a time. Don't forget to like, share, and subscribe for more mind-bending space science. And remember, in the vastness of space, there's always more to explore. That's just one cosmic mystery explained in minutes. If you learned something new today, give it a like and let me know what you're curious about in the comments. I'll reply to every single one. And if you want to see more space, science, and imagination, all in under 10 minutes, subscribe for more. Thank you so much for watching. I'll see you next time. That's 1 minute. See you tomorrow.